Hello everyone. Today we will discuss the difference between the delta variation and the other delta variation. In the first delta variation, we can see that the variation of the coordinates are allowed at a same time, and in the actual path APB and the varied path AP dash B, you can see that at the endpoints, there is no variation in the position coordinates. So this type of the variation is known as the delta variation. And at the endpoints, we can write for the T1 and T2 time that delta Qk is equal to delta Qk, and this is equal to 0 because there is no variation at the endpoints for the two paths APB and AP-B. But here you can see that at the constant time there is allowed a variation in the position coordinates or generalized coordinate. But this variation is, you have to note that it is at constant time t. Here when we move from P to P dash, time is constant and position is varied. So this type of variation is known as the delta variation. The other type of the variation that is also called as the delta variation. In this variation, the time as well as the coordinates are allowed to vary, and at the endpoints the position coordinates are kept fixed or constant. They are not going to be changes at the endpoints. Here you can see that APB is the actual path and A dash P dash B dash is the varied path. After delta t time, we see that the position of the point P is changes to P dash. So here you can see that the time is also varied and the position is also varied. But at the end points, here you can see that the position coordinates of the actual curve APB and the varied path A dash P dash B dash are same. So in this variation, we can write at the end points that delta Qk1 and delta Qk2 is equal to 0. But there is allowed a variation in the time as well as the position coordinates. So let us say here that a point P is here for the actual curve, and after delta t time it reaches to P dash for the varied path A dash P dash B dash after delta t time. So we can write as when P reaches to P dash, then we can write for the position coordinates. If you see the diagram, then Qk will be equivalent to Qk dash, and so we can write it as Qk plus delta Qk, because there is the a difference in position coordinate. So that difference will be written as delta Qk, and we can write this variation delta Qk as Qk plus delta Qk plus Qk dot into delta T, because if you see that when you move from P to P dash, then this is your Qk, and then when you move from P to P dash, it becomes your Q K dash. So this difference this delta qk difference will be, first we can understand it like, first we will move from P to here in horizontal direction, then we come to vertical direction. First we move here and then we move, first we move here and then we move here at P dash, so it is a vertical distance. Now here you can see that there is no variation in the time and there is a variation in the position coordinate, so this variation will be written as delta qk. Right, for the vertical movement you will write delta qk, and for horizontal movement you will write qk dot into delta t. So from P to P dash delta variation, which allows a position coordinate as well as the time coordinate, so we will write it as delta qk. Now here you can see that this delta qk will be equal to delta qk plus qk dot into delta t. This is the horizontal distance and this is the, because of the vertical distance. This is the first delta variation. If you remember that your time was constant but there was a variation in the position coordinate, and this is in delta t time we move from P to horizontal distance, so it will be a velocity q dot k. So your equation now becomes qk plus delta qk plus q dot k into delta t. Let us say it is equation number 1. Now if there is a function which have this delta variation and it is the function of the generalized coordinate, generalized velocity and time, then we can write this function in terms of the delta variation as sigma k del f over del qk into delta qk plus del f over del qk dot into delta qk dot plus del f over del t into delta t. Now we will put the value of the delta qk from here. You know that delta qk is equal to qk plus delta qk plus qk dot into delta t. So we have written here. Now your relation now becomes sigma k del f over del qk into delta qk plus del f over del qk dot into delta qk dot. We have written this term separate and this term separate. So this is the first bracket, then plus sigma k del f over del qk into qk dot plus qk dot double qk double dot del f over del qk dot plus del f over del t into delta t. It means that in the above equation you can write it as like this equation. So here you can see that it will be written as delta f plus df over dt into delta t. So you can write here the delta variation as delta is equal to delta plus delta t into d over dt. This is a very important relation and will be used in action problems. Thank you.